What I want you to notice is in this video here is this is a very good horizon video that we can use for perspective. Notice that as the clouds get farther and farther away, they move down towards the horizon. So anything that moves closer to the individual, in this case, who is taking the picture here, look at that big cloud up on the right, top right-hand side, and the clouds on the right side. They move towards you on the right side, and the clouds on the left also move towards you. But they move down as they move towards the horizon level. That's all I want you to get out of this. Just a very quick refresher at how perspective works. And let's get into the heart of the video and see something very interesting about observations that we should have picked up a long time ago with weather balloons. Here we go. Now that we've looked at perspective, let's take a look at this here. This is the 4 positions I want to show of the sun going around on a flat earth. The green object at the bottom, that is the observer. So I'm trying to show this from the observer's perspective. But we lose something here when we're looking at it from a top-down viewpoint. So let's go ahead and rotate this. And now let's take a look at the sun, how the observer would see it, the person in green, as the sun got closer and farther away in a 24-hour period. Correct? Now we know that the sun actually hits a vanishing point. However, if you could see that sun the whole way, this is what it would do. It would have this rising and lowering effect, just like we just saw with perspective with the horizon that we understand. So this is what we would expect to see on a flat earth, with the sun moving in a circuit around the earth in a very tight circle in a 24-hour period. So now that we've taken a look at this, let's take a look at what science says the model is. So here we're going to show the sun and the earth, and the sun, in this case, being 93 million miles away and not moving, and the earth in this case is the one that's rotating. And here we have the observer in white at the end of this rotating stick here, and I'm taking the earth away so that you can see exactly what happens when a balloon is in the air. It doesn't matter. Once the balloon is up in the air, you can do whatever you want with the earth. It doesn't matter. The tilt of the earth doesn't matter anymore. Nothing matters anymore. Why? Because the balloon is up and independent of its own. It's just out in space. Correct? It is independent and on its own. Now, the reason why I'm still showing the rotation here is so that you can see that it's going to no matter what time of day or night, or depending on the time of day or night, will depend on its little variation as far as how it's facing the sun or not. And at 93 million miles, we have now the balloon is only going to change by what? The diameter of the earth. So at some point during the day, it's going to, let's give it 8,000 miles. It's going to be 8,000 miles closer to the sun when the white dot there is in the position closest to the sun, and it's going to be 93 million miles plus 7,000 or plus 8,000 miles farther away. Now let's look at this on a scale. We're changing by 8,000 miles in respect to 93 million miles in one day. Alrighty, here's some graph paper, and each one of these squares equals 1 million miles. And guys, I'm cheating here. The sun is way smaller than what's on here, and the earth, which is the little star there, that is way smaller than that also. You wouldn't even be able to see it on here. Remember, it's 8,000 miles across. Each one of those squares is 1 million miles. The sun is less than one of those squares across. Here we go. The earth is going down to 93 million miles away. There it is, 93 million miles away. And like I said, you wouldn't even see it with your eyes in this scale. The sun you would barely see as almost filling up one of the squares to the left. So with that in mind, and that you couldn't even see the earth on here, which represents, 1/10 of a block would be 100,000 miles. And we're talking about 8,000 miles across on the diameter of the earth. So rotate that 8,000 miles, your viewpoint, from one time of day to another, and rotate that, you're going to move roughly 2 or 3 of those blocks at most from the middle of winter to the middle of summer towards and against the sun. And so how much of that would you see change in the sky over the course of any particular time versus what we saw before? You would see nothing, no difference at all. If you sent up a balloon, no matter what, no matter where your position was on the earth, it should look the same. If you can see the sun, it would be at 90 degrees. Can you see now how the sun rays always have to come in at 90 degrees? I hope this makes it clear. So as soon as you saw that sun, see, I try to explain this, and maybe I can do a visual on this, or somebody can help me with this. To me, you would be in the bottom of a kind of a tunnel looking up, and as soon as the sun rose, it would be there right on top of you, and until the earth turned away, it would disappear on the other side of the well wall that you were in looking up. In any case, I hope you can see that little spin of 8,000 miles isn't going to change how a balloon would see the sun. Imagine a balloon doing that little 8,000 mile trek around in a circle every day. Not the earth, but a little balloon with a camera looking at the sun. Would the perspective ever change? No, it would never change. Well, if it did, it wouldn't be enough for your eyes to pick it up. So now let's look at some of the balloon launches that I've put together, and let's take a look at those. And I think we're going to find out something very interesting here. Alrighty, in this first balloon launch here, this is in Norway, and you can see the date is July 24th. I got to tell you guys, there's a lot of balloon launches out there, and there's no data as far as even the date or where it was launched. That's a shame. But I think everybody should be more in tune to what they need to look for now, because this is what's amazing about these balloon launches that we have not even noticed. Remember, as soon as that balloon gets off the earth, there's no 23.5 degree tilt or anything else like that it has to deal with. It's in space. And as such, look at the only thing you have a perspective of, you have two perspectives here. You have the sun, which is supposedly 93 million miles away, yet it's got a hot spot over the earth. You just saw the graph paper. Do you think you would see that at 93 million miles away? Come on. And you've seen much better hot spots than this, haven't you? In any case, the perspective you have here is the Earth from Norway in July. Now, I want you to remember the two animations we had. The first one was the one going around a flat Earth where we would have the sun higher or lower in the sky depending on how close it was to you. And the second one with the graph paper, as far away as the sun was, it didn't matter, did it? It wasn't going to change anything. It's just way too far away, and you're not turning enough for it to make any kind of difference. So let's take a look at the next balloon launch, which is becoming a lot more valuable than I thought. And that is my own balloon launch. The Phoenix, Arizona launch that we did September 27th, and I keep getting confused on the date. Maybe it was the 28th. I remember for a long time I had the date wrong, so I think we actually did it on the 27th. And anyway, this is my balloon, and this was roughly, well, the altitude stopped at 34,000 feet. This might have actually been much higher than that. I just don't know because, like I said, you remember the results there. In any case, Phoenix, Arizona, and again, there's the sun. It's barely actually in the picture with the obviously flat Earth under it, but you can see there. Notice also the angles of the sun rays in all these different videos. There's nothing obscuring it, nothing for the sun rays to be split up with, and yet you got all these sun rays coming at different angles, and yet they're supposed to always come in at 90 degrees, correct? Yeah, right. All right, let's take a look at the next one. All right, this is the Texas Panhandle, and this is also in July, and you can see how that turned out there. So again, notice all the different things here. Notice the Earth, the perspective to the sun. Note the two different ways that science says we're at 93 million miles, and we showed the perspective of the other way. Of course, we believe in the flat Earth model, but in any case, I just wanted you to have several ones to compare. So the Texas Panhandle here in July, and we've got a little bit of a GoPro type of deal here. In fact, this way, if you look at this video, you can see that the top left corner, I've left the names of the videos on there, so if you want to look them up and take a look at them. This is one of those GoPros where it goes convex, concave, and flat, depending on what's happening with the balloon. Again, this is an excellent view of all the different angles of the sun rays coming in. And last, and probably actually least here, we have a balloon launch which had panoramic views of the sky. And believe it or not, the moon was in this one. They caught the moon and the sun in a panoramic type of capture. Now, there is one problem with this using a panoramic lens. And I believe I know how to do it right, but I'm not positive. Now, there was no date. But it's obviously in the winter. You can look down at the Caucasus Mountains, which is where this was taken above, and they were obviously quite snow covered. So if it wasn't, unless they're snow covered year round, I don't know. It's not that far north, these mountains, so I don't know. From where they look, they don't look like they would be covered in the summer anyway. So, but look how low the sun is here. And that is the midpoint. When you look at that video, the sun comes close to you, then it gets far away at the midpoint down there, and then it comes up again to your left. So it goes away on the right, goes down to its farthest perspective there in the center, and then comes back to the left. And in between, you get the moon. I would love to know what date that was when that was launched, because they got both the sun and the moon there, and it's too bad it's panoramic, because you could probably better make out what the phase of the moon was and everything with that. In any case, you've seen these 4 different launches now and the different perspectives here. And here's the big thing I want to put together and show you. So again, remember the graph paper at the 93 million miles away, and then remember our first example where we showed that if it's a flat Earth and the sun is that close, it would do just like the horizon example. It would show it rising and falling apparently in the sky, the sun, in reference to the Earth. So let's take a look at these 4 together right now. Okay, they're all 4 together here. This is amazing, absolutely amazing. You saw by that graph paper that there should be absolutely no difference in the way the sun looks. I don't care if it's winter, spring, summer, doesn't matter. In fact, 3 of these were taken in the summer. The only one that we don't know of for sure is the one there in the bottom left, the Russian one. But the others were taken, in fact, 2 were taken 3 days apart from one another. Here's what I want you to notice. Here is the fascinating thing. Here's the thing that NASA and science and nobody that believes in the globe is going to be able to explain. If we are 93 million miles away and we launch a balloon and it's no longer attached to the Earth, it doesn't care what the freaking, it doesn't matter anyway, with the 23.5 degree tilt and all that BS. What I want you to notice here is look at the distance from the sun to the Earth. And what I tried to do was I tried to get these as close as possible as the altitude, but the altitude shouldn't matter. It doesn't matter if it's 30,000 feet up or 500,000 feet up. What's the difference? We're 93 million miles away to that sun, correct? And the surface of the Earth is always at eye level in every single one of these videos. It's always at eye level from the time it launches on the ground to the time it gets to this where I've taken these photographs until the time the balloon bursts and it comes back down. The horizon is always at eye level, which means, of course, that it is a flat plane. It is not a globe. And people are misunderstanding. They're really underestimating the power of that. But in any case, look at the difference. Look at the Russian one, which I think was in the winter and would be the farthest away from the sun if that's the case. Look how low that sun is to the horizon. And you can go back and look at these 4 that I just showed you so that you can see the big picture. Then you have the one that's in Norway. that would be the next closest to the Earth. And then the Texas and the Phoenix one, they're pretty close, and they're actually pretty close on the map. Now, of course, the time of day would make a difference if the sun is close, and that's where we need to get some data from some of these other balloons. And I hope everybody else starts keeping better tabs of when they were launched and the different times they're up there and what time of day and just everything. But I can tell you that the Phoenix picture was taken roughly 9:30 or 10 local time. The Texas Panhandle picture that you see there was taken about 11 a.m. if I've got everything there correct, about 11 a.m. there. So they should be relatively the same, with Texas being slightly higher because it was in the Texas Panhandle. That is farther away from where the sun is in relation to where it goes around the Earth. So, and that works out. The Texas one is a little bit farther away than the Phoenix one. All four of these happen to work out. Like I said, the Russia one is the questionable one, but assuming it's in the winter, all four of these work out. It doesn't really matter what time of day it is in Russia. If it's in the winter and you look at it on a flat Earth map, the sun would be the farthest away. And this is an amazing thing, I think. So, to me, this shows that 93 million miles away, all four of these pictures, I don't care what time of day it is, as long as that sun is there, it doesn't matter. It doesn't matter where it is on the Earth. At an 8,000 mile difference with 93 million miles, how can you explain all these differences in how high the sun is to the horizon? You can't do it. And when you look at these different videos and everything, you'll see that the ground looks the same. It's not that we have cameras that are much more zoomed than the others or anything like that. In fact, the only camera that is not out of the ordinary here, or that is out of the ordinary, is the Russian one, because it's using a panoramic type thing. But go and look at that video, because even when it's coming down the sides, it's still closer to the Earth than these others. All of these four match up with what you would expect to see on a flat Earth. At 93 million miles away, these pictures should be identical. The sun should be identical distance above the Earth, and it should look the same way distance from the Earth, and there should be no hot spots on the Earth. How do you get a hot spot at 93 million miles? Now you've got some kind of perspective of the real distance and the real sizes we're dealing with at those distances, the relative sizes. I mean, you got to be really seriously into your own denial and getting into your own mental health issues to start denying this now. These are things that we can see every day now, that if we just start looking at it from a different perspective, you can say, hey, yeah, why should we ever see a difference at 93 million miles? What's the difference if it's 9 a.m. or 2 p.m.? As long as that sun's above the horizon, it should look exactly the same. It should always look the same distance away from the Earth, shouldn't it? Yes, it should. To me, this is a visual proof that the Earth is flat and that the sun goes around the Earth. It's the only way you can get these kind of different pictures. Do it with it what you would. There will always be the deniers. But let's just keep throwing up the proof, guys. Oh, and I wanted to thank, I was really kind of bummed out the other day, and I went and I happened to notice, guys, by the way, I'm not hardly ever looking at the comments anymore, and I got to do another video to explain some things that are going on, what I'm doing. But I happened to go to the video where I was talking about support for the channel, and there were people on there that hate me so much that they were lying, making all kind of lies about how I left my job and all these kind of different things. And it dawned on me, it's like, if they hate me that much, then if I give up and quit doing this, that's just going to make them happy. So they have really motivated me to keep going here. So with that, I'll end this video. To me, this is fascinating stuff. We just got to get more videos compiled together with the date, time, and then we can draw it on the flat Earth and say, okay, this is how far away the sun would be on a flat Earth. Because the sun's always the same distance away on the other model. I mean, the only difference is if it's the middle of winter versus the middle of summer, the sun should be a little bit closer, 2 or 3 of those little blocks closer in January versus July. So, these Texas Panhandle and Phoenix ones, and all but the Russian one, the sun should have been close, according to the globe model, according to the heliocentric model. So by 3 million miles or so, big deal, if it's even that much. In any case, that's the end of this video. Hope you enjoyed it, guys. This is, I mean, these things are right in front of us. How many more things are right in front of us that we're just missing? Thanks, guys. I appreciate your help and your feedback and all that. Take care, guys. Bye.